All right, so this follows on from the previous question, which was super duper easy. This one is also pretty easy. There's just maybe two tricks to it. So we're finding a particular solution to a differential equation. So if you know the differential equation is this, and you're also given like a boundary condition where when t equals 4, h equals 1, then obviously you can go one step further and you can find out what the c value is. So this isn't new to you. You've done this stuff before, but I just want to talk about just maybe one part of this. Actually, there's probably just two things that we need to talk about. One of the things that you're going to want to see is that this section here where it says substitute t squared plus 9, make that u. That's because the derivative is present. So the derivative of, so t's up the top and t squared is on the bottom. So we've got a derivative present, and you've seen that before in term 2 when we were doing integral calculus. We called it the reverse chain rule. Questions like this, questions like this. There's other ways to integrate that as well. You could probably use integration by parts or something like that. But this is all revision for you, so I'm not going to go step by step by step. Eventually, though, when you integrate it, you should be here. And then the whole crux of this video, the reason we're doing it, is because we need to know what that c value is. So to find the c value is relatively easy. You sub in 4 and 1 for t and h. So when you do that, 4 squared is 16 plus 9, that's going to make 25, and that's where that 25 comes from. Now, your textbook work solution here has missed a trick at this point here, because the square root of 25 isn't 5, it's a plus or minus 5. So there should have actually been two answers. So we'll kick off from here, the second last line. C is actually equal to -4 or 6. Now, even though I've said C is equal to -4 or 6, we can probably disregard one of these solutions. So let's sub both of those solutions into our equation and make sure that both of them make sense. Okay, so with this square root sign inside of our function, I've subbed both of my numbers in here. With the square root inside of this function, we're going to end up with some sort of relation like this. I haven't sketched it yet, but it's definitely going to, as soon as you put a square root in here, you're going to end up with two y values for every, for some x values. Now, that's not allowed because we were told this is a function. They're using function notation here. And the only way that you can take this and turn it into a function is if you only let this guy be positive. So we don't actually need whatever answer comes from the negative version of this. So you can probably get rid of that negative there, in which case this 6 is the one that we can disregard. So be careful. As soon as they tell us it's a function, essentially this square root doesn't do plus or minus anymore. We just go with the plus. There's our answer.